Hi, in this video, we're going to continue to talk more about setters and getters. Now, I want to do talk a little more about instance method. Now, remember in the getter and setter for make, we make sure it's a Honda Tesla, right? But if you look at the initializer, I can actually put um, some other brands in there and it will succeed. That brand or something, right? It will succeed. And if I print out car, right? Cars make is bad brand, even though we did intend to make sure the make is only Honda or Tesla. So what should we do? Well, one way we can do is we can, copy this check into the initializer. But hopefully when I use the word copy or duplicate, it sets off yet another alarm because code duplication is very, very bad. Okay, so if we don't want to duplicate code, what should we do? Think about it for a moment. Okay, hopefully you come up with the answer that I come up with, which is we can simply just call the setter from the initializer. Okay, so we can simply, instead of setting the attribute directly in the initializer, we call the set make so that it will go through the check in set make. Okay, and now to call another instance method from an instance method, we always start with the instance, right? So, and in this case, the instance is self, and we just do instance dot name of the method as usual. Okay. So that's what this is trying to say here, and but is that it though? So if this succeeds, then it's good. Then the make is set properly. But what if this fails, right? So we actually should try to handle the case when it's failed. So we should check, okay, if it's not, meaning it returns false, then what should we do? Well, it's kind of it's up to the kind of the requirement or the design of the class to figure out what to do here. One possibility is that we actually set the make to some sort of default make. So I'm gonna say default make. I'm gonna make this into a constant. The default will be unknown. And right, obviously I cannot just say default make because this is the class constant. So I have to start with the class and there. So now if we run this, we should at least kind of have a clue that when we see the make is unknown, then we probably passed in an invalid make. Okay. So, like I said, what you actually do here, that's there's no like a single right way to do it. We chose to set it to some default value. There are other ways to do it. One particularly good way that I like is actually using exceptions. So we'll talk about exceptions later. Exception is just to report an error. So um, that's another way of handling an invalid make in the initializer, in that invalid attribute value for in an initializer. So your turn to write some code now. So in the car in init method, instead of setting the model and the year attributes directly, should use the setters that you wrote previously. Now, if the set model fails, the default value should be unknown again. And if the set year fails, then you can set the default value to, let's say, 0. So here is a question that we've gone through what a setter and getter is, and then the setter, the most important job for a setter is that it validates the input. Why do we have to do this in the setter? Why not do this in the user or client code of the class? Right? We can very well, we can just make sure we don't set it to some bad values, right? Well, as the implementer or the designer of a class, we just cannot assume the user or the client of the class will do the right thing, right? As we saw earlier, they can be evil, or they can be incompetent, or they don't know what they're doing, right? And even if they are none of that, even for users that just everything they mean good, it's still wrong that we have to spread the burden of validation to them, because there may be many users, right? And we really do not want each and every one of them to know the internal details of our class. So we cannot just expect them to know all these things, all the intricacies of our class. Now, when they do something wrong, I mean, we want to inform them, and that's why we have to return values. And we should, document what are good values and all that. But again, it's just not the right thing to rely on them to know exactly what is right for our class. And this is an idea that's actually called data encapsulation, right? And it's going to be very important as our system grows in complexity. I want to just kind of put the Python setter and getter in perspective in the greater world of programming, and where we are with the setters and getters. So, but first, we should, when we want to access attributes, we should always use setters and getters, right? That's why we wrote them. And that's not just true in Python, but it's true in pretty much all the object-oriented programming language that I know of. Right? You should always use setters and getters to read and write the attributes. Here's the question. Does Python actually enforce the use of setters and getters? And the answer is no. In Python, there's no way to fully enforce that. So And by that, I mean, even though we wrote the, let's say, the setter for price, like even though this is, we should call the setter price, I can still set the price to something horrible. Okay, Python will allow me to do it. There is no way to hide the attribute from the client code. Unlike C++ or Java, where it's actually possible to mark the attributes private so they cannot be accessed directly by the client code. And the reason for that has to do with Python's design philosophy. One of its philosophy is that it trusts the programmers are well-intentioned, that the programmers would be responsible and the programmers do not abuse the system. So whether you agree with that or not, that's another discussion, but that is the thinking behind Python's design. So Python does not try to hide things from the programmers. Now, having said that, the way we implement, the way that I just showed you, how to implement setters and getters, is actually not a very quote-unquote Pythonic way to write setters and getters. The Pythonic way does mitigate the risk of accessing attributes directly, somewhat. Again, it doesn't fully prevent accessing anything directly, but there's a better way to do setters and getters. However, the Pythonic way of doing setters and getters, it's kind of it's syntactically kind of complex, especially for beginning programmers, which most of the students in this class are. And so that's why I am not showing you the Pythonic way of writing getters and setters. And because I just want us to get to understand the concepts first. And this concept apply not only in Python, also apply to all the other object-oriented languages. I will see if there's time to cover the Pythonic getter and setters at a later time, and if not, it should be covered in 3B. Okay, and while we are on the topic of Python design philosophy, I think since that we have seen quite a bit of Python code already after 4 or 5 weeks of this class, so we actually are equipped to understand some of the Python's design philosophies. And many of those not just apply to Python, but apply to programming in general. So there's this thing called a Zen of Python. Might want to click on that, and it's very short, but it's a very interesting read. Okay, there are not that many items here, but I picked out a few that I thought are that we can actually understand given what we've learned so far. So one of the zens of Python is that explicit is better than implicit. And there's no better manifestation of that than the self parameter, right? That is always, when you want to create an instance attribute or call an instance method, you always explicitly start with the self parameter, even though you are part of the class already. So explicit is good in Python's design philosophy. And then simple is better than complex. So that's obviously true, not just for Python, not just for programming, and probably in any kind of engineering or even in life. Like I think Einstein, at least Einstein was always attributed uh, the quote that we should always make things as simple as possible, but no simpler. So simple is good. And one of the many manifestation of this philosophy, one thing is that we really should not have duplicate code, right? Duplicate code, we copy and paste, we increase the size of the source file. Things just get, and if we change one thing, do we change the copy? That's just not good. So no duplicate code, keep things as simple as possible is good. Another thing, that's another item in the Zen of Python, is flat is better than nested. And that's why I keep emphasizing that whatever code that you write, it should have as little nested blocks as possible. Okay, it will take some practice to get to get to the optimal level of nestedness, but this is a goal that we should strive for. Flat is better. And then finally, readability counts. That is something that we've emphasized from the beginning. The readability of the code is very important, both for your understanding and and anyone who reads your code. Okay, and this is actually partially enforced by Python because of the indentation. Indentation matters in Python, and that at least helps the readability quite a bit.